Welcome back. In our previous video, we discussed the different types of concrete, the proper sequence for concreting, and common errors that can lead to cracks in structures. Today, we will delve into this critical issue of concrete corrosion and the essential raw material testing that helps prevent it.
Remarkably, it was completed just 7 years.
இது இஷ்யூ ஆச்சு, யாருக்கோ ஒரு குழந்தைக்கு ஏதோ ஆச்சுன்னா சும்மா
It's going on.
Okay. On visual inspection, we come to know that this damage might be extensive.
A massive concrete structure. What could have caused such a disaster? Well, it could be a number of things. Maybe they used chlorinated water in the concrete mix, or perhaps the rebar was not prepared properly. Dust or moisture trapped inside the rebar can create the perfect environment for corrosion to thrive, or maybe the building was not designed to handle the load it was put under, or the soil conditions were not suitable. But considering the builder's experience and the location of the building, we can probably rule out the last two options. Let's see what the investigating officer have to say.
Main inspection outcome, and as reported by certain residents, is that there are a lot of chloride content in the rods that has been used construction. So that has led to the erosion of the rods, and that has led to the chipping away of the plaster and the mortar. So that is the issue that have pointed it out. So some of the residents have been rectifying it for like the past 2 years. But what we need now is, we believe, an entire structural reassessment of each and every unit. Okay, only then on the corridors on the entire building. Only then we might be in a position to comment whether whatever damages or whatever the defects, if any, if they are pointed out, whether we'll be in a position to rectify it. Or if we end up in a situation where something is structurally defect, then probably the thing should go for redevelopment.
So if that's the case, how did this corrosion happen? Concrete corrosion is a serious problem. When it happens, the steel inside the concrete starts to expand, which can cause cracks and weaken the structure. And once those cracks are there, it's like inviting bunch of troublemakers into the structure. Corrosion causing agent can easily slip through these cracks and attack the steel. There are a lot of things that can cause corrosion, but one of the biggest culprit is using substandard materials. If the steel or the aggregates are not up to par, they are more likely to corrode. This is where we have discussed in our sequence of concreting is raw material testing as a second process. To prevent all of this, we need to be very careful about the material we use and how we mix them together. Every single material, from the sand and gravel to the steel and the admixtures, needs to be tested and approved before we use it. IS 456, this is the primary code for concrete works in India, covering requirements for all stages of construction. But every material has a specific testing standard, often referenced alongside IS 456. For instance, IS 2386 outlines the testing requirements for aggregates. If you wonder, I am highlighting IS 383 here but stating IS 2386. Both IS 383 and IS 2386 are relevant standards for aggregate testing in high-rise and complex structures. However, they serve different purposes. IS 383 provides specifications for the quality of coarse and fine aggregates used in concrete construction. It covers physical properties like size, grading, specific gravity, water absorption, and soundness to meet the required standards for strength, durability, and workability of the concrete. While IS 2386, methods of tests for aggregates for concrete, Part 4, mechanical properties, specifies methods for testing the mechanical properties of aggregates. It covers tests like aggregate crushing strength, impact resistance, and abrasion resistance. That's crucial for assessing the ability of the aggregates to withstand the stresses and loads that high-rise and complex structures will experience. For high-rise and complex structures, it is generally recommended to follow both standards. In addition to these standards, there may be other relevant standards, just those related to chemical properties or other specific types of aggregates. Also, to remember to comply with the local building codes and regulations regarding aggregate or any other material testing. As we mentioned earlier, admixtures, let's understand the role of admixtures in the concrete. Admixtures play a crucial role in concrete. They are like additives that enhance the concrete's properties. Some admixtures can help reduce permeability, making it harder for corrosive agents to penetrate the concrete. IS 9103, this standard covers concrete admixtures including accelerating, retarding, water reducing, air entraining, and super plasticizing admixtures. Fly ash is a popular admixture because it offers several benefits. IS 3812, this standard covers fly ash testing. It's cost effective, environmentally friendly, and can improve strength and durability of concrete. However, it's important to note that fly ash can also have some drawbacks such as curing and settling difficulties in cold weather that may need to add some other admixtures. Excess water. Using excessive or untested water in the concrete mix can significantly increase its permeability. This means that water can more easily penetrate the concrete and create pathways for corrosive agents to reach the rebar. When rebar is exposed to corrosive agents, it can lead to corrosion, which can weaken the structure, as we have seen already. By adhering to proper standards and conducting regular testing on raw materials, we can significantly reduce the risk of concrete corrosion and ensure the long-term durability of our structures. We will continue our discussion on concrete corrosion and design mix approval in the next video. Until then, take care.